Thank you, everyone. How are you feeling? I think there have been a lot of community events, so I do not know how many of you have been sleeping more than a few hours. I haven't because I had to do the judging as well, but everything's fine, so please bear with us. It's a little bit harder topics today in an innovation stage, a little bit more energy, and tonight we have another party, but let's discuss about some technicalities and about sovereign shard. I think one of the first things would be that why sovereign shards? As we look around the space and as we hear feedback from the community, there are use cases in which they would like to customize chain parameters, they would customize tokens or economics, validator set, block round, finality, all those kinds of things, and they would like to have it to run for their own set of applications. And in general, that's why sovereign shards exist, because dApps sometimes need specific use cases. Or, for example, institutions. Institutions, public or private, they want to control their own data, they want to control their own validator set, they want to control their own transactions. They are a little bit more closed. They would still like to enjoy the global market of what a blockchain means, but they do not really want all the data to be public or all the connections and everything around that to be public. So institutions can find a solution through sovereign shards and then have private setup, complete flexibility, reliability, and one of the most important things is seamless interoperability. I think about that one we will talk a little bit later. Let's talk first about features. So everything beautiful you have on MultiversX, main chain you will have on sovereign shard, and you can enable or disable them. This means staking, delegation, governance, validator management, ESDT tokens, WASM VM, all the contracts which are running on main chain, and you choose to run WASM VM as well on the main chain, on the sovereign chain, then all the contracts on the main chain can be deployed directly on the sovereign. Everything will work the same. All the things we have from reentrancy protection, overflow protection, all the goodies are there, easier to build, easier to port from one chain to another as you feel fit. And then all the integration on top of it, like API, microservices, wallet, explorer, everything is bundled together in the sovereign shard SDK. No more need to rewrite things, no more need to rethink things. So you will have the things about like relay transaction as well, guardians features, usernames, whatever you want, and whatever you don't want, you just disable all kinds of things and then go forward. So what can you do with sovereign shards? Or even right now, if you run the VM on much powerful machines, and with both consensus and state and everything, you could achieve, for example, more than 4,000 swaps per second on X-Exchange smart contracts. That's like a super huge number. I think we are the first one to reach these kinds of numbers on a VM which is running open contracts like WASM. So it depends on you. When we have the main chain, we have to think more about what will validators do, what is the purpose. We want to have low entry barriers, so not so high performance machines, but for games, for your own applications, for perpetual dexes, even for checkses, which they want some private transaction, non-private transaction, everything could be built on a sovereign shard using blockchain technology, leveraging the technology, and adding your own customization. I'm quite happy that more and more people are coming in. It starts to feel like you have energy. So I think you drink your coffee, which is good. But what's more, in Sovereign Shard, we already have the consensus V2 Adrian presented yesterday. So right now we have, if you run with the same setup as mainnet, you already have almost 2 times transactions per block, almost 2 times gas limit per block. So it's faster, you can execute more, which is great. Then on the setup, you can have it private or public, enable whatever you want. And by enabling or disabling a set of functions, and by making the configuration of your sovereign shard, you can make it proof of authority, proof of stake, or you can make it delegated proof of stake as well. And you can play with the governance contract as well if you want. One of the important things is gas. Because how do we make gas to be custom for a sovereign shard? We need to have it custom. So we will create, it's not yet created, a gas module, economics module, which is configurable by you. This will be by setting up your own gas schedule, your own gas token, and whatever other rules you want to add here. It might mean that you want to have a set of addresses who have free transactions, or all the addresses have free transactions because you are having a subscription-based chain. Whatever feels free. And one of the important things here is that we eliminate completely the base token. So everything will be ESDT token. So from a configuration perspective, when you generate your sovereign shard config, you have to write the token ID you want to have as gas token. And that's it. About virtual machines. Right now on a sovereign shard, we run in one shard, we run the system VM, which is built in Go, and the WASM VM by default. And those two can communicate together in an atomic execution format. So everything is executed or non-executed directly. But this means that as how we built our ecosystem and how we built the modules for the VM, we have an interface, we have a set of helper functions for storage and blockchain context. Then you can build your own VM and connect that VM inside a sovereign shard. You can eliminate the WASM VM, you can add the new VM as well. We can discuss about later how to do it, but there are a few interfaces you have to implement, and under it, you can have your own VM running whatever you want. If you want super control, and if you would like to go into implementing smart contracts, for example, in Go, in which you control completely everything, then you can build smart contracts directly in the system VM using that methodology. That's possible as well. A little bit more code from you, but you are the builder. So, what could all this achieve? Imagine a world of the perfect Web3 games. The perfect Web3 games are the ones where even on-chain data is, all the game data or all the state changes in the game data are written on-chain. But right now, even if we have cheap transactions on MultiversX, it would still cost you thousands of, let's say $1,000 per day to put all your moving pieces on-chain when you start to having 100,000 or 1 million users, or even 10,000 of users which are constantly playing. So on a sovereign shard, you would be able to, let's say, whitelist all your servers which are running the game. All those servers which are running the game information could be decentralized, meaning that You give out to a few validators to run the servers, and those servers build a consensus and write all the data, all the changes on-chain to the sovereign. And they do it for free because they are running the game. And they can do a few transactions for free for the for whatever happens with a few players. And here is your the beauty of it is that you will be still completely connected to the global market. That's one of the things we wanted to resolve. That a sovereign, it's not only an L2. We like on Ethereum, where you live in a silo, you need a lot of bridges, you need a lot of trust, because as we look around, in a lot of bridges, they have like a multisig, or even in the ZK rollup or the optimistic rollup versions, you have like private sequencers. So the node, the entity which is writing all your data on L1 is centralized. It's only one, and all your funds is connected to only one. So they could say that it's decentralized, but it's not. And here we come with introducing all the logic all the logic through which you can connect to the main chain, and through which you can have seamless bridging between the main chain and the sovereign and back. We introduce that code inside the validator binary, and inside the consensus, and inside the processing. So that means that if your validators, your 10 validators, 20 validators, 100 validators, and you always select one leader at every block, trying to build a new one, if that leader does not build that block correctly, and it does not include the bridge transactions, it does not include all kinds of cross-communication which is needed, then the block is not signed, because the validators are running the same software. They want to ensure that bridging is happening, so block is not signed. Next leader will hopefully do a better job and build a better block which will be signed. The same principles as we have in case of the main chain. So validators must process all the transactions which are coming from the main chain. And the finality is given by the main chain, and the transaction processing model is actually the same as the cross-shard model for both ways, for both main chain to sovereign, from sovereign to main chain. But why don't we add, let's say, just another shard, and to make it specific, because that would make more complicated on terms of the meta chain, on terms of our node management, and it would not offer you such builders, such customers, you couldn't do so much custom things there. So right now on the main chain, you have the cross-shard transactions where you first execute on the sender shard, you take out the tokens from the account of a user, and then that transaction, after it's confirmed, after the block header in which that transaction was included was confirmed by the meta chain, that transaction will be executed on the destination chain as well. And using this kind of model, we do the following. We do the same. So the user has only to deposit into a safe contract and say what he wants to execute on the other part. Then the validators on the sovereign shard will check all the entries onto this safe contract, and from all these entries, they will create smart contract results, as we have on the main chain, and as we have for multi-USDT transfer in case of cross-shard transactions. And they will execute these kinds of smart contract results as a cross-shard execution by knowing that, okay, I had it executed on the main chain. The balance was moved into the safe. Now I can execute here. And when you can have token transfer plus complete smart contract call as dictated by the user and in the name of the user. So it's not execution, it's not happening in the name of the bridge. One of the things like why right now it's happening between bridges, between Ethereum and MultiversX, or between all kinds of bridges, between L2s and Ethereum, L2s to L2, is that the execution by model is happening in the name of the bridge smart contract. It's not happening in the name of the user, and they have to do all kinds of magic tricks there to make it somehow look like it's on the name of the user. In general, the bridge smart contracts become heavier and heavier. So, but as we execute it in the name of the user, we can revert it in the name of the user. Even if the execution failed, tokens are transferred back. And then it's simple as that. Deposit, multi-ESDT NFT transfer, all your tokens, whatever you want, deposit, call an address, call a function, call arguments. One of the things is that as we run on the same public-private key method, all your accounts, so you will have one account on all sovereign shards. Actually, you will have those accounts on every sovereign shard, but you will use the same interface, the same method, the same wallet, the same X portal, and everything is executed in your name safely. When we go back, sovereign to main chain, you have to send your tokens to the bridge smart contract and burn it. The validators, out of all the bridge transactions, will create we call it outgoing transaction, and they will add the BLS multi-signature at the end of it. And then the finality is given when the outgoing transaction is processed. These are a lot of technical terms, I know, but bear with me. It's fun. One of the things we will do is when we will do the bridging back and forth, we are already researching to have ZK proofs for all what's happening in these kinds of bridges, and to add the ZK proofs generation, creation, validation directly to the sovereign validator set. So it will be based on proofs. This means less data is transferred between sovereign and main chain, and it's proven by the whole system that those kinds of things are correct. And also by doing this, we will add opcodes of ZK proofs, validation of ZK proofs directly through Wasm VM as well. So bridge operations from perspective of the validators will look like bridge operation, list of addresses, tokens, function to call, gas limit, BLS multisig. As the validators of the sovereign have to post transactions on the main chain, it means that they need EGLD. So you will have to have a hot wallet in which you have EGLD for the validators to post those transactions, but in general you will earn more on the sovereign shard in order to have this kind of funds. Plus, if you do it correctly, like your custom functions, you will be able to earn from the main chain staking delegation ecosystem as well. So in the end, by building everything inside and building everything inside such a way as we have the cross-shard transactions, you have one wallet, one explorer, complete usability. So simplest integration of all services, cross-interaction with any contract in the name of the user, execution. And imagine you play a game, you win an NFT on the game, and you receive that NFT on that sovereign shard in the game. And with one transaction, you list it directly on the main chain on one of the marketplaces. So you are directly connected to the global market. You are not living in a silo. The user doesn't have to make like bridge, and after that a list, and all kinds of multitude of actions. Everything is like seamless. Everything is the same as if it would happen on the main chain. When you integrate like paymasters and relayers, what was presented 2 days ago, there is no more need for users to buy gas tokens, and they can easily pay with their own tokens all the operations. So, and complex operations across chains are safe because rewards are built into the whole ecosystem. So it's just like an extension of the sharded system. This is how we think about it. So we again try to resolve all kinds of hard problems in a correct way in order to have like full usability and full good experience for both users and both builders. And builders do not have to rewrite and rethink and introduce bridges and introduce a lot of code, which we know that takes a lot of time, takes audit, takes this, takes that, and that. And when we can do it seamlessly, I think that's a win-win for everyone. All right, it was a lot of talk about technology. Let's go into economics and customizability of it. In general, we want everyone to do whatever they want in their custom mode. But when you want to give out trust to all the users who want to use your sovereign, you have, in general, trust in case of proof-of-stake systems is based on how much is staked. So you can choose your validator set to have a minimum of delegated EGLD in the main ecosystem, which is slashable. So all this data is on the main chain, it needs slashable. But the beauty of it is that projects, so the validator delegates in the ecosystem, the representation is from the sovereign validator smart contract, we call it that, and then he is still earning all the EGLD rewards there. We might make this kind of earning rewards like with compounding effect, or make it for you to decide whether you want compounding or not. But this way, you want, I don't know, 10 or 100 nodes, and you would say that, okay, those nodes, every node has to delegate 100 EGLD. They delegate 100 EGLD to subscribe to your sovereign shard in order to become validators. Then they are slashable for those 100 EGLD, because if they do something stupid on the sovereign, so it means that the other validators from the sovereign will sign a BLS signature to slash those kinds of things. You will earn the EGLD as you would have, like normally, and then you can earn all the extra rewards you are getting on the sovereign, and you have custom entry and custom rules. Custom rules even means that, okay, in the configuration you can set on your contract that only whitelisted addresses could go into it because you want a proof of authority. So we have a lot of contracts here, and I don't think we will go into everything, but the sovereign validator, it will be like a liquid staking contract, somewhat, a little bit changed. Earn EGLD, choose whether you compound or not, and your funds can be slashed by the other validators on your sovereign chain if they sign a message. And you can define earning of other tokens as well. This kind of earning other tokens can happen here in the main chain, but it can happen on sovereign as well. Then we have a chain factory, which maps all the sovereign shards, maps all the configurations, and then it will give you deterministic chain IDs. It might be random or not, in order to have everybody to look there, all the integrators, and just have the chain ID directly for your sovereign, all information in one place. Then in the configuration config, you have minimum, maximum, slashing rules, extra criteria, fee management. The the definition of the guest token, let's call it the native token, it will be the guest token. You can define block time, size, whatever you want. And here, if you need, as you start building on the sovereign and you need more custom things, just bring us there. Then the guest tokens, by default, we would recommend you to have wrapped EGLD, but it's not necessarily our job to it's a recommendation, because that way your validators will earn wrapped EGLD, so they will have funds to process all kinds of bridge transactions, and it's actually good for the ecosystem to use wrapped EGLD for all the gas. As more the token is used, the more the economics is better. You can set free transactions, and you can even set different fees for, let's say, especially outgoing transactions. Because as a sovereign, you like all the liquidity is coming into the sovereign. And then when you want to bridge out, you might set a fee, as we have right now on the chain. And one of the things a lot of you asked about is when EVM, and why not EVM? I'm not a fan of EVM, as you might have seen from Twitter, because all their issues, and I hate the approve infinity or allow infinity hacks, and they happen for everyone. So please, when we have EVM, do not use the approve infinity, because I will bash you. No, but I can write a little bit on Twitter. Don't take it as a tag, but please, if you use EVM, let's make somehow in order that users will not be phished and they will not have wallets drained. So let's be mindful about those things. As you will run EVM on a sovereign shard, it means that it will cost pennies to do transactions. So the user can put multiple transactions in, it will not cost a fortune for them to do it. I understand that in Ethereum everybody does allow infinite because. All right, we will have still the built-in guardians that will help your users, that they cannot really, even if they give out the seed phrase, they are still free. But we do a few more things in order to be compatible with the WASM VM and the ESDT system especially. So you will have token contracts with wrap ESDT to ERC, and then you have contracts from ERC to ESDT contract. We will have a set of standards built, then you can change, modify, take fees, whatever you want there. And we have to introduce new interoperability codes into an EVM and to the WASM VM as well to have seamless integration. This means that you could launch a Uniswap, a 1inch, or whatever application you choose from there, which works on ERC20 tokens, and then when the user wants to take that ERC20 token and move into the main chain and trade it on one of the DEXs on the main chain, and the main chain works on ESDTs, he will do it again seamlessly. So yeah, I feel your energy out in the room, but yeah, these are some good things, so thank you. And now Radu will go forward with the demo, and then we can have questions and answers after.
Yep, thank you very much, Robert. Okay, let's see that everything is still working here. Okay, good. So what we are trying to do today is, like I said before, deploy a bridge smart contract. Like Robert said, there is a specific format for the logs and events that have to be interpreted by the nodes on the sovereign chain. We are going to deploy also a sovereign chain and do a transfer from the public testnet to the actual sovereign chain. The main code, or most of the code for the sovereign chains, is common to the MX chain Go, to the normal node. A few components differ. But the consensus, the processing, the state, the peer-to-peer, everything, the guardians are common for both the sovereign chain and the normal node. The MX sovereign SC is the repository where you can find the bridge contracts. These bridge contracts are supporting ESDTs right now, and you can bridge tokens from the public testnet to the sovereign chain. You also need a sovereign notifier Go. This is going to run on a public testnet observer on the shard where your bridge contract is going to reside, and this is going to notify right now the validators and the observers from the sovereign chain about the information that comes from the public testnet in our case. Okay, so at first, let's go and enter the MX sovereign SC, and here we need to we can see the ESDT save folder. So, I am here in the MX sovereign SC, the ESDT folder. I'm going to do a deploy contract. Just a sec. Okay. I'm going to use MXPy. I'm going to use the Explorer, the wallet. I'm going to use a little bit of shell scripting to do the demo. Increase the font. Control plus. Okay. Okay. Good. Okay, so I built the contract, and I have snippet here, and I'm going to deploy it. So I'm going to use MXPy to deploy the contract. Like I said, we are going to deploy the bridge contract directly on the testnet, on the public testnet. We can see the contract address. And by default, the bridge contract is paused. We have to also do an unpause. Okay, let's look at the transactions that we did on the public testnet. So, like I said, this is our contract. I'm going to copy the address. I did the unpause on the contract, and in my snippets, I'm going to update the address of the contract to the newly created address. So, I have the address. I could now actually go and start a sovereign network. For this, I have prepared two machines, one where I'm going to run the actual public testnet with 3 validators and 1 shard, or 4 validators and 1 observer, and another machine for the observer of the public testnet that is going to notify the sovereign nodes over there. So I'm going to connect to the sovereign testnet machine right now. I am in the so here you can see the MX chain Go. I said that's where the code resides. The proxy, where we have the gateway in order for our Explorer and our wallet are waiting for a gateway and for an elastic indexer there. The takes-gen to do some transactions directly on the sovereign chain, and the deploy Go to have the config files generated very, very quickly. So if we go, this is right now internal Explorer that we have. It's for the sovereign, and nothing happens right now. The API is actually waiting for the sovereign nodes to start the gateway to be able to request the necessary information from the gateway and for the Elasticsearch. So let's go here. I'm going in the MX chain Go. in the script, in the testnet script. And here we have to do some customization. So at first, script testnet. Okay. Let's see the variables.sh. So let's put the round duration to 4 seconds, for example. We need just one shard for the sovereign chain. The number of validators is 3. I want one observer. These are all customizable, and the consensus size should be 2. And this should start us a sovereign chain with a runtime of 4 and 3 validators and one observer there. Okay, I saved it. What we also have to do is go into the MX chain Go, into the sovereign node. So like I said, most of the code is common, but there's going to be another binary, the sovereign node binary, where there are a few other configurations needed for the sovereign chain. Okay, let's see here. Let's put back 3 billion gas per block. We are going to be able to run the 3 billion gas blocks on the sovereign chain. You can also change the inflation for your new sovereign chain directly from here. And the notifier config, this is what I said, the sovereign notifier has to work on the public testnet observer and be able to feed the information to the sovereign nodes from there. So we are going to have the identifier deposit, like Robert mentioned there. We are looking for some subscribe log events with deposit, and I have to put the newly address of our contract there. So we are subscribed exactly for the bridge that is of interest for us. You have to put the mode to client here. The URL is the IP of the testnet observer where the sovereign notifier is working. I put it as the IP of this other machine that we are going to start shortly. So right now, if I finished all the configurations for our sovereign node, I could actually start the deployment of a sovereign node. The deployment of the sovereign chain actually starts a testnet with 3 validators and 1 observer, and is also going to do some transactions with the TXGen to see that smart contracts are running on the sovereign chain, that move balances can happen there, that ESDT transfer happen there. So let's start it. So right now, what happened is a new testnet has been created on this machine in the MultiversX testnet folder. We have the node, whoops. Let's see what happened here. Okay, good. So like I said, 3 validators, 1 observer. We also have the logs, and we can look in the logs what happens there. So right now, there is no connection. We didn't start the sovereign notifier on the public testnet observer, but we are round 1, nonce 1. If I do another refresh, hopefully other blocks are going to come. Yep, so round 3, nonce 3. And if I do the refresh also here, hopefully also on the Explorer, yep, we can see the transactions. 38 seconds ago it started, and also the blocks started going here, and we have 4-second block time from 24 to 28. So we managed to start the sovereign chain very, very fast. If you do the configurations, it takes literally 2 minutes to start a sovereign chain. Okay, so looking at the logs, we can see that there is no connection that could be done in order to get the information from the actual public testnet. So I have to go on the sovereign observer there. I just clone the MX chain scripts. I set the environment to the testnet, and I'm going to stop if something is running here. I hope not. And I'm going to just start the observer. Just a sec. So for the node, like I said, we have one node. It has been configured. Let's look again on our public testnet explorer right now. We can see that we have the contract on shard 1. So our observer from the public testnet has to run necessarily on the on shard 1. Okay, internet problems. Okay, let's do it here. Elro nodes. Nodes, node 0, config, and cat the prefs toml, so that I can show you that we have it on the destination as observer on shard 1. What else we have to change is in the external toml. Okay, this machine seems not to work as expected. Let's try it again. Not here in the logs, in the config. Let's do it again with a cat external toml. The host drivers config. So like I said, this is the server that is going to feed the 3 validators and 1 observer, the values. So we have to enable it true, put it on mode server. This is the current local address. And by enabling this, the sovereign chain nodes are going to be able to get the information from this node. Okay, let's start the node actually. Okay, script start. I want to start the node. Right now, the node is going to start. It's going to synchronize the state from the shard 1 from the public testnet, and hopefully after this we are going to be able to see in the validators from the sovereign chain that the nodes are actually processing extended shard headers, which are the actual information from the mainnet. Okay, let's see a little bit more. Arrow nodes, nodes 0, logs. Let's see the minus 50 for this one. Yep, So it started, it found some of the connections to the other machine that are listening for the mainnet information. And now it's processing the transactions and the blocks from the public testnet. Okay, let's do another refresh here and see if we also have extended shard headers in the blocks, meaning that information from the main chain, from the public testnet, is also coming to the sovereign chain. So right now it managed to add 41 block information from the public testnet here. And it's going to catch up to be synced completely with the public testnet. So right now everything works. We can do a transaction, a bridge transaction from the public testnet directly to our sovereign chain. So in my snippet, I have a default deposit. So it starts from my address, a PEM file, and it does exactly what Robert said. We do a multi-ESDT transfer. The first argument is the address of our contract that we have populated right before. We just want to do one single transfer. We are going to transfer wrapped gold from the public testnet. There is no need for a nonce. This is 1, the value 1 followed by 18 decimals. And the format for the log events that are going to be generated, or the method that we have to call from the endpoint that we have to call from the contract, is deposit, and for which address on the public, on the sovereign chain, we want the 1 EGLD to be transferred from the testnet. Okay, let's go back here and do the default deposit. Okay, so this is the transaction from the public testnet. It is a multi-ESDT transfer, so it's from me to me, but the action is actually one wrapped gold from my account. So we are on the testnet explorer. One wrapped gold from my account goes to the contract, to our bridge contract for the newly created sovereign chain. And in the logs, we are parsing this log here. We can see there is a deposit for this address, the address that we set there, and encoded here are the tokens, the nonces, and the quantities that we want to move there. So here, the first part is a unique identifier for the, like an auto increment, the number of bridges that have been done through this contract. This way, we can uniquely identify the transfers and not process 1, 2 times. Okay, so let's refresh again here. This is the log from the validator on the sovereign chain. And right now, if I look at this address, this is the sovereign explorer right now. If I search for this address, I can see that 1 minute ago I got 1 wrapped gold from the sovereign chain. So the bridge worked here. I can do another one and see how fast it's actually working. So it's 11:27. It should be less than 1 minute until the processing happens here. So this is a very, very short demo about how you can set up a sovereign chain, how you can customize what you need there, the round time, the different economics variables there. So it should it should work quite easily. You just have to customize the configs and then deploy a sovereign chain very, very fast. And be able to transfer the tokens from the public testnet, the devnet, also the mainnet, and test something on the sovereign chain. Do not test with the mainnet, sorry. Yep, okay. So, yep, the second transfer came here 19 seconds ago. So, like I said, in less than a minute, the transfer can, you can see the transfers on the sovereign chain. What I want to do right now, very, very shortly, is try to change the on the sovereign testnet. Adi mentioned in his presentation that we have the consensus V2. Yep, I can show that actually here. So what happened before? What happened before when a block was processed on the mainnet, and what happens right now is we have 1.5 billion gas that is processed just by the proposer at first, and only after he processes the maximum 1.5 billion gas, he sends the block to the other validators in the consensus group to also process that. And this time, the validators, the other consensus group members, are actually waiting just for the proposer. In consensus V2, the proposer just selects the transactions and sends the transactions to all the validators right then, and the proposer and the validators can process in parallel all the transactions. This way, we can process in 4 seconds like 3 billion gas without any problems on a sovereign chain, because this parallelization happens there. Okay, I think we can have some questions and answers. I'm going to change a little bit something here and try to do a 1 second block time and try to process 2 billion gas on the sovereign chain. Just 1 second. So let's put here back 2 billion, 2 billion, and 2 billion. Okay, and in the variables, let's put 1 second. Save. And here I'm going to stop it. And do the deploy sovereign again. So right now the sovereign explorer is not working anymore. We have to wait for it to start again, but if I did the changes correctly and I saved all the files here, so the round direction is 1,000, and in the economics I put back 2 billion gas. We should see 1 second blocks on a sovereign chain with 2 billion gas actually being able to be processed on a sovereign chain. Okay, let's see if it starts. Okay, we have the transactions, we have the blocks. And yep, you can see 1 second blocks over here. Right now they are not full. The TXGen is just starting right now, but in a few seconds, the TXGen should be able to start and process. So you can see the blocks are 1 second apart. And yep, on a sovereign chain, we already have the 1 second block times. Okay. Okay, let's see if also the xgen is starting. Okay, something happened. Okay, let's. I think we can stop here. I would really wanted to also show you the 1.7 billion gas on a benchmark that I did last night, just to be able to see that. Okay. Okay, so I think we can go further with the presentation. We have the exactly the last slide right now. Oops. This way. So, yep, the demo was today, so anyone could try to test the sovereign chains starting today. They can connect them to the public testnet or the public devnet or a testnet that they have created and do the bridge transfers from the testnet to a sovereign chain. Yep, all the MultiversX features are also present on the sovereign chain. The bridges are integrated directly into the processes. The alpha release will have the integrated bridge on both directions, from the main chain to the sovereign and from the sovereign to the main chain. It's going to have the sovereign staking validators in order to be able to compensate the validators for the job that they are doing. We are going to have the chain factory and the config SCs. All of this is going to come late this year. So by the end of this year, the alpha release should be ready. The beta release is going to have the gas token as an ESDT there, custom gas fees, and the fee module when you can customize whatever you would like on the fees there. Right now, we do not have an epoch change. It runs on epoch 0, and all the activations should be done with a round activation. But in Q1 2024, so early 2024, we should be able to also incorporate that in our beta release. And afterwards, yep, we are going to have multiple VMs, maybe the EVM, maybe some other interpreters over there. We are going to have dApp support for the builders. We are going to have the integration in the wallets and also in the X portal. And yep, next year we are going to have the actual first sovereign launches. Thank you very much.
I think our time is a little bit up. There are other presentations out there, so we could take at most 2 questions, and after that, you will find us wherever in the rooms or here, and just come to us to ask more questions directly. Are there any questions? Super fast.
The validator of the shards. Assign a transaction every time a block is processed on the second layer to the main layer, or is just the deposit, they need to observe the deposit from the chain, but they are not signing any kind of transaction on the main chain?
No, they are not signing any transactions. They are looking just at the logs and events that come from the smart contract, from the bridge smart contract. We are looking only on finalized blocks, so the blocks cannot be reverted anymore. And in the future, we would like to also have maybe zero-knowledge proofs sent to the sovereign chain, so that you need less and less information from the main chain.
And also, you can customize the SDT that can be transferred on your sovereign shard, or any kind of SDT can be transferred on
No, we enable you to customize whatever you want there.
You could whitelist or blacklist some ESDTs directly in the bridge.
Okay, perfect. That's
One more question.
Yep.
It's back there.
Hi. Is there a way that you can configure the sovereign shard to make data public? As right now on the mainnet, everything is public. Is there a way that you can configure that some assets are private and only the owners of those assets, they can view that?
You can do it by hiding your network actually and showing out all kinds of data, what you want. It's possible with the peer-to-peer configuration that in that time, Julian will have to answer more questions, but on peer-to-peer, you can make private connections and everything to be private, and then you have an explorer where you show some data out of those private state changes, whatever you choose. Thank you very much, and there is it.
Yes, so hello again. Of course, you can have multiple private P2P networks. Actually, we're going to experiment with that on RCV160, where we've redesigned the full archives feature. And you will see that, that they can work very, very good. So actually having more than one P2P network will help the messages pass and be contained on only one network, essentially.
Thank you very much for your question and attention. So any more questions, we will answer it after. And
Thank you.
Thank you.